Before we talk about surface area, it's kind of helpful. You don't have to memorize these definitions or anything like that, but you do have to be familiar with the words, because you'll see them. First of all, what's a three-dimensional figure? What would, like, nothing? What's the difference between a two-dimensional figure and a three-dimensional figure? Not three sides, but three dimensions. So like if I do a rectangle, don't copy this thing. I just do a two-dimensional figure. It's got two dimensions, length and width. But if I added this, I've added a third dimension now, haven't I? I've added like depth. Okay, that's what a three-dimensional figure is. We are three-dimensional figures. We have height, we have width, and we have depth. So a three-dimensional figure is a figure that has length, width, and depth. Three dimensions. Okay. There are certain types of three-dimensional figures. There are ones that have just sort of like straight segments in them, line segments. There are ones that have curves in them, or maybe circles in them. We give them different names, okay? So for example, actually, I need to get in. Yeah. Okay. The right prism. It's a 3D figure. Where the ends are polygons, which means it could be a rectangle, it could be a triangle, it could be a pentagon, it could be a hexagon. And the sides are rectangles. So think of, you've got the ends of a three-dimensional figure, and then what we connect the ends are rectangles. So as an example, this would be a right prism. The ends are five-sided pentagons, and they're all connected by rectangles. Okay? This here's triangular prism. The ends are triangles, and what connect the triangles on the end are rectangles. Okay? If they are all rectangles, like this, and remember, a square is a rectangle. This is called a right rectangular prism, where they're all rectangles, the ends and the sides. So that's a right rectangular prism. 3D figure. All sides, and actually we don't call them sides when we talk about three dimensions. We call them faces. So get used to that, faces are rectangles. So like this 3D figure here has 6 faces. It's got a face in the end, which is a square. It's got a face on the other end, which is another square, which are types of rectangles. And it's got 4 rectangles that connect those 2 squares. So it's got 6 faces. Okay. A triangular one would have how many faces? Count. 1 and 2, 3 and 4 and 5 rectangles. Okay. So that would have 5 faces. A cube, you guys should be familiar with. It's a right rectangular prism. Oops. Right rectangular prism, where all right rectangular. Where all the faces are what kind of shape? In a cube. What's so special about all the faces, all the shapes that make up a cube? They are all, yes, they're all equal, and but what kind of shape? Squares. Where all the faces are squares. But yes, absolutely, they're all the same. Right, so we would have a cube, or have a cube, so that looks like that. Right. So what we're going to do is we're going to find the surface area of some of these figures. And how do I find the surface area of any 3D figure? You find the area of all the faces and add them together. Find areas. Find areas of all the faces. Like, are you running a paper mill back there or something? And add them together. So you just have to determine what shape all the faces are, find their areas, and then add them all together. So we're going to look at certain types, and today we're only going to look at 2 types. How do I find the area of rectangular prisms and cubes? Okay. So let's say the rectangular prism here, we're going to call it length, width, and height. I mean, I could have called it length, width, and depth. Okay, but I'm going to call these length, width, and height. How many faces are there on this? Sarah?
5.
5?
4.
2 on the end, 1 in front, 1 on top, 1 at the back, 1 at the bottom. 6, right? So, but some of the rectangles are the same size, aren't they? Okay, so I can make a formula to find the surface area of a rectangular prism. And this is what it would look like. Remember, the long one here, horizontal is length, the vertical we call height, and the slanted we call width. How would I find the area of the front face? Length times height. Length times height. But there's 2 of them, right? There's one at the front and the same one at the back. So I'm going to double it, times it by 2. So we've just found the area of front and the back, and I'll even put them in different colors. How would I find the area of the top? Remember, it's a rectangle. Length times width. Length times width. But there's two of them. Top and bottom. So I double it. And finally, I got the right and left sides. How do I find the area of this? It's a rectangle. Width times height. But there's two of them. So I double that. So this is the front and back areas. This is the top and bottom areas. This is the right and left areas. And then I just add them all together to get the total surface area. You will always get that formula. Okay, I will always give you that formula.
But the first one, what is it on there?
Length times height. Yeah. Good. Okay. For a cube, I could use the same sort of formula, but I don't need to. I can do a really simple formula because aren't all the edges the same? Aren't they all called S?
I have a question.
Sure.
But how do you know when
Oh, yes, yes. We'll do a couple of examples. All I'm doing right now are formulas. We'll do a couple of examples right after. Okay? Where did that disappear? Saying you. So, how do I find the area of this? If I call each side S times S times S. What's another way to say S times S? S squared. That's for one of the faces, right? But how many faces are there? 6 of them. So the area of one is S squared, but there's 6 of them that are the same. So I just do this. So it's a very straightforward formula. I will give you this one too. So let's look at a couple of examples. Where we have a rectangular prism and a cube. So remember what I called them in the formula. The horizontal one was the length. The slanted one was the width. And the vertical one was the height. So really, we just have to use the formula. Remember, it's 2 times length times height plus 2 times length times width plus 2 times width times height. And then you just plug the numbers in. What's the length? 30. So 2 times 30 times the height, which is, we call it 6. So that's the area of the front and back. Now we do the top and the bottom. 2 times the length of the top, which is still 30, times the width, which is, what's 7. Finally, 2 times the right and left sides. Well, the width is, and the height? Right. So 2 times 7 times 6. And then basically you use your calculator to find the answer. So we would get, if you used your calculator here, you should get 360 for the first one. Okay.
Yeah.
Plus 420. Plus 84. And that gives us what? 864? Yeah. What are the units? Remember, we're finding surface area. Centimeters, area. Area is always squared. Area is always squared. So whenever we find the surface area, it will always be centimeters squared, or meters squared, or millimeters squared, or inches squared, or feet squared. Always squared. Second one, we've got a cube, which means that every side is 5. They're all 5, the length, the width, and the height. So how would we calculate a cube? 6 times whatever the side length is. Actually, I'll write the formula first, just to remind myself. 6 times whatever the side length is squared, which means 6 times 5 squared. Now you got to be careful with this. Do I do 6 times 5 first, or 5 squared first? 5 squared, always exponents first. So 5 squared is 25. So I'm going to end up with 6 times 25. Again, you can use your calculator for that. You should get 150. And what would the units be? Feet squared. Excellent. Now, you guys should have taken this previously, finding the surface area of these things, but perhaps the next thing we do is new. What happens if we start pushing square or cubes and rectangular prisms together? Like if I gave you a shape like this. Yep. Yes. Okay. So there's a couple of different ways you could do this. First of all, this thing, when we have more than one figure pushed together, its special name is a composite solid or composite object. So more than one 3D object combined. So yes, that's one strategy you could do. First of all, how many cubes are in this figure? 5, right? But we can only see 4. But there is one below this one and behind this one. Okay. So one strategy we could do is, well, all the faces are the same, aren't they? How do I find the area of one face? I know it's 2 centimeters. How would I find the area of this?
5 squared.
Yeah, 2 times 2, right? Or 2 squared. So one of the faces The question is, how many faces can we see? Remember, you can look at an object from 6 different views. From the front, from the back, from the right, from the left, from the top, and from the bottom. Okay? So let's keep track of this. Let's go front. Actually, it's not going to work out to 30. Let's have a look. Front, back, right, left, top, bottom. So looking at it straight from the front, how many faces can you see? Remember, you can't see these faces if you're looking at it directly from the front. These 4. I can only see 4. From the back. Well, the back of this one, the back of this one, the back of this one, and also the back of the hidden one too, right? So I can see 4 again. How about if I look directly from the right? 3. This, this, and this. And it would be the same from the left. Yep. But I'm saying you're looking at it directly from the front.
Oh, not.
Okay. You know, so like if I'm looking at you directly from the front, I can't see the top of your head. I can't see the sides of your head, right? So you got to be, yeah, you got to, I've drawn it so that you can see multiple views. How about the top? If you look directly down on it. 4, top, 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 top. What's that? Yes, but you can't see it because it's hidden.
No, she's saying the one that's hidden is inside. Oh, is the one that's under the wall one? No, no.
You can see this one from the top, this one from the top, this one from the top, and this one from the top. You can't see the top of the hidden one because this is blocking it, right? So you can only see 4.
That on the back, there was also one. Yeah, like the shape, like the one that was.
Are you talking about from the back? Yes. From the back, you can see 4. You can see the back of the hidden one.
I know, I thought you meant something. See,
Oh, sorry.
that was like the back of it.
Oh, I see. Okay. Gotcha. What about the bottom? 4. So that means that we can see a total of 22. I know each one is 4. So the surface area is going to be, well, the area of 1 is 4, and there's 22 of them. So 4 times 22 gives me 88 centimeters squared. There is another way you could do it, but I sense this might be very confusing. So I think I'm going to leave it. What you could have done, I'll just say what you could have done. I'm not going to go through the entire calculation, but what you could have done is you could have split all the cubes apart. Okay? So separate all 5 of them. The surface area of one of them would be 6 times 2 squared, right? So you find the surface area of each one. But when you put them back together, certain sides are going to be hidden, aren't they? Certain faces are going to be hidden. So you can actually find it by subtraction. But that can get a little complicated. but subtraction works well in some cases that I'll show you. I would say for one like this with cubes, you do it like this. Okay. All right, let's look at another one. Renee uses 3 pieces of foam to make a chair, shown to the right. So each one is like a rectangular prism. And there's 3 of them. And she sticks them together so it looks like a chair. What she wants to do is she wants to cover the whole thing in fabric, including the bottom. Okay? The question is, how much fabric does she need? So this is one where we could find the faces separately and add them together. Or we could find the area, surface area of each one individually, and when we put them together, subtract what becomes hidden. So I'm going to show you that way. Let's pretend that we've got this one, that we pulled it right out. Yes, it's snowing. You guys okay? I can't believe I have to compete with snow. So let's find the surface area of one of them. Remember, this is the length, so the length is 0.6. The width is 0.2. And the height is also 0.2. So using our formula, it was 2 times the length times the width. So 0.6 times 0.2. That takes care, remember, I've pulled this one out from the other 2. So that takes care of the front and back. The top and the bottom. Well, length is, or sorry, that should have been length times height. The length is 0.6, the width is 0.2, so it's the same thing.
Kind of a random question, but instead of doing practice, can you just do all?
You can. And then finally, the right side, the area of one of them on the right side is width times height, so 0.2 times 0.2. And there's 2 of them. And then we add them all together. So using our calculator, we should get, what do we get here? 1.2. My brain's fried.
0.24.
0.24, thank you. Plus 0.24 plus 0.08. And when we add those, we get 0.56. That's for one of the prisms, right? So that's if I pulled it out and found its entire surface area. The total surface area. There's 3 of them, right?
What about 0.48?
Go ahead. This plus this is 0.48. Right? 0.24 plus 0.24 is 0.08 or 0.48. Plus this is 0.56. Try again. 0.24 plus 0.24 plus 0.08. Good. You all right? Okay, how many of the prisms are there? How many are there that make up the chair? 3. So the area of one of them is 0.56 times 3. But here's the problem. When I put them back together, don't certain sides become hidden? Like for example, I think I've got 2 sheets. Like here, I've got 2 triangular prisms. When I put these together like this, how many faces disappear? 2, both of these, right? When I put them together like this, how many faces disappear? 2 again, 2 rectangles this time. So you got to think. Let's finish this and then you can ask your question. How many faces disappear when I put the 3 back together? When I put this one on top of this one, how many faces disappear? 2 rectangles here, right? Well, can you read that? So 2 rectangles disappear here. 2 disappear. And also, when the front connects to the back, another 2 disappear. So a total of 4 long rectangles disappear, don't they? I have to subtract those away. No.
Also, 4 sides in total.
Right, because every time you put 2 3D figures together, 2 disappear. So the area of one of them is 0.6 times 0.2, right? So the area of one of them is 0.6 times 0.2, but how many of those disappeared? How many of these disappeared? 4. So we're going to times it by 4. And then I got to subtract. Remember your order of operations. Do the multiplications first, then subtract at the end. So 0.56 times 3 gives us 1.668. Minus 4 times 0.6 times 0.2 should give us 0.8. And when we subtract, we get 1.2 meters squared. That's how much fabric she's going to need. Okay, Sienna?
Our text would we have to do it this way, or could we do it the other way?
You could do it the other way. Absolutely. Because both ways are correct. So, but remember what the question says, just to finish the question. She's got 2 square meters of fabric. Does she have enough? She's got 2 square meters of fabric. She needs this much for the chair. She has enough. So Renee has enough fabric. Okay. I'm not going to do the next example. It's, oh, of course you can. Absolutely, if you want to. But it's a little, like, this one's a little, this one's a little tricky. Because you're painting this whole thing, but what do we're not painting the roof of the warehouse and the office building. We're not painting the floors, okay? And we're not going to paint the doors and windows. So what you really have to do is you have to find the surface area of each one and then subtract away everything that's not being painted. So you have to subtract away the top here. You have to subtract away the floor. You have to subtract away the roof here and the floor. You have to subtract 3 of these because there's 3 of them. You have to subtract the windows. There's 4 of them. You have to subtract the little door. No. Okay. What I want you guys to know are ones like numbers 3 and 4 in exercise 3.3. So what? No. So for next Wednesday, okay, because we're going to do the second lesson tomorrow in class. Do exercise 3.3, but don't do number 5. No number 5. Okay. Next Friday.
Right.